good day, and we are Kuwesa, and today we will talk about the implementation of the interpolation process. So first, let's move on to the theoretical side, where we talk about what we want to do and why do we want to do it. So first, let's define what is upsampling, which is the theory or the application that we want to actually use in order to perform this activity. So upsampling can be referred to as the way to increase a sampling rate for to be used as an input to another process. So for example, you have very low uh, or very few input signals or input data, and we want to actually upsample it to have more or increase the sampling rate for the output. So what we will do is, for example, we have the signal, and that signal will pass through an upsampler, and that would be uh, the output for that process would be an increased or a higher sampling rate than what it was originally is. So for the codes, again, we will use the conventional CLC clear all and close all in order to reduce or remove all unwanted processes. And we have this input functions or input processes where uh, we define or input our sampling factor, the length of the first input signal, the frequency of the first and the second sinusoidal waveforms. And we for the interpolation process, we would use the MATLAB defined function, which is interp, with the function of sine of 2 pi multiplied by the first or the frequency of the first sinusoidal and multiplied to our values or our array here, which is a value from 0 to n minus 1, which is uh, on this system. And that equation will be now added to sine of 2 pi multiplied by the frequency of the second sinusoidal and multiplied again to our array. So using the or interpolation function, we will now perform a subplotting wherein we want to put both visualizations in a single graph or a single visualization in order to closely compare them to each other. So without further ado, let's try to use our given codes. So for our sampling factor, we want 5. You can actually put any values there as long as it was carefully researched or used in accordance to its purpose. Then we want to enter a length of an input signal which is lower than usual or fewer. For the previous experiment, which we performed downsampling, we have 100. So for our input signal here, we want that to be lower in order to see what is the difference between upsampling and downsampling. So with this, we want to actually input, I guess, 9 for our input signal. Then for the frequency of the first sinusoidal, we want 0.1 and 0.3. These input values will help us see what really happens uh, with upsampling. So with that, let's see the graph. So as seen in this visualization, our input sequence is relatively has fewer frequencies. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, which was predefined by our inputs. Then our output sequence actually upscaled or created an higher frequency rate or sampling rate with our output. So that is what happens in upscaling. So that's all. Again, we are Kuesa, and thank you for listening.